Hello, everyone. It's nice to be here, although I couldn't be possibly in person over there due to personal engagement here. And maybe next time, who knows? So nice meeting you all virtually. This is Farshad Kazemi. I have studied computer science here at WLRRec University. Right now I'm working as an MLOps at Arteria AI. And I'm here to present our work on code review recommendation systems, specifically on how state reviewers and state recommendation can stall the project's progress. Without further ado, I'm going to start presenting. Contributing to projects, you may say I'm like a great, awesome developer, even a 10x one, as some say, making an awesome change. I want to contribute to a project, go fast, quick, never think. So I asked this crystal ball, please give me a reviewer. We may call it code review recommendation or anything else. We don't care. So it comes up with this reviewer, which is 99% match. And that's Shane. So he's a great reviewer for this patch. I'm really happy. I'm going to wait for him to come and review my code. But nothing happens. He just leaves. Why? Because he already left the project. So there's no one to review the code. So I hear myself echoing. Could you just mute yourself, like the mic? Sorry. Perfect. So what happens is we are back to square one. So I'm going to sit there waiting for the reviewer. And the worst part, it's not going to happen only once. It's possible that this situation goes back and forth like multiple times. Some guys are busy, some has moved to another projects. And this means it's going to cost us time, money, cause the developer to be confused, which means like lower rate of contribution for open source projects, and it's going to cost the companies and the maintainers money. With that in mind, we started studying this phenomenon called stale review recommendations in different aspects: their prevalence, their distribution, and their duration of staleness. I'm the first guy here in the picture, unless I know it's not that hard to identify. And you can reach me out to these these channels, either email or my website. Also, if you don't know, like it's 2 p.m. over there, it's morning here, but over there it may not be the best time to listen. So feel free to scan this QR code and listen to this. It's a podcast. It's like I use the Google Notebook, so feel free to listen to that later, just in case. Okay, going back to the presentation. What happens when we submit a PR? The PR has like a bunch of changes. It goes in a code review recommendation. If set up properly, is going to recommend a bunch of people. It may have different criteria for those recommendations. Maybe he recommends one because he knows the authors, he had previous interactions. Another one may have maybe familiar with the files when they change. Another guy could have could be a newbie, just joined the projects. He wants to learn because there's learning opportunity. But none of these prevent recommending the stale reviewers, i.e. those who already left the project, but we still don't have any idea or don't have the context. Actually, a recent study by, it's not recent anymore, it was 2023, research is moving so fast. Study actually shows that almost 22% of the negative feedback has been caused by these stale reviewers. They're somehow irrelevant. But why they exist? Let's have another look at what happens beneath the curtain. So here's another project. We call it Project X. No relation to X, Twitter, or anything. It's just random name. It's odd to use X these days. So we have a senior developer, which is Max, our second author, and Shane is the staff engineer here in this case. So when a review comes in, what we do is basically look at the reviewers' interactions, their knowledge. It's more likely the staff engineer to be recommended, so he gets recommended to review. He is a fast and quick guy, so he just goes in and review the code. But then he decides just to leave the project. Normal developer behavior these days. So now when a reviewer comes in, the CR system or code review recommendation system have no idea. He keeps recommending Shane to review those codes. Then Max has to pick that up because Shane is no longer contributing to the project. It goes on for a while. Max do more reviews. He becomes more familiar with the code, and then by the time he do enough contributions, the CR system deemed him as the better candidate, so start recommending him. But it means there's like so much time being wasted in the middle until the histories change, and it means the senior developers are more likely to be lingering in the recommendation list long. And don't get me wrong. Like you may say, like this is not going to happen that often, but it does. Like you can see, it's in these days people go from Microsoft to boost farming, so that happens. With that in mind, we studied 5 different on 3 different projects. So these are the approaches. The orange ones are more practical and non-naive models, meaning they have their multi-objective. They try to optimize different things at the same time. The blue ones are less, we call them naive approaches, because they just aim for optimizing one thing, either to increase the learning rate to the maximum, like meaning helping new developers learn, or RetentionRec means like its main goal is to recommend someone that's been with the project longer. But then there's reviewer set size of difference in different projects, and that will also impact our study. So we also studied the different reviewer size from 1 to 3, and in this project we studied 3 projects: Roslyn, Rust, and Kubernetes. We studied different aspects as we started to this conversation about it, about the state recommendations. First, we wanted to know if they're prevalent, how prevalent they are. Then we wanted to know how long they linger, and how long is it between the recommendation and where they have already left the project. And the last one is about the distribution, who is being recommended more often. And is it okay to just remove like 1 or 2 people and then it's going to be magically okay? So we started with the first recommendation, with the first issue. In this one, as you can see on the right side, we had 5 different CR approaches. Let's start with the first one. We divided the project history into different quarters, and numbered them from 0 to like 8 in this case. And then you can see that on the x-axis. And then on the y-axis, we have the percentage, like what's the share of the state recommendation over all the incorrect recommendations that's been made by the CR system. Then we repeated that for different reviewer size, from 1 on the top, 2 in the middle, and 3 on the bottom. And we repeated that for all 3 projects. So what you can observe is that there's like an upward trend in these projects, and it's not just for WLRRec, which is one of our recommendations, CR systems. It exists for other projects, for other approaches as well. And it's not only one project; it's among all the projects. You may see that there's like there are 2 extremes, one on the bottom, one on top. Both are naive approaches, meaning, as I said, like they're not practical, so they're not basically being used actively in a project, and they didn't prove to be okay. They just aim to actually we use them as base cases here. So and now, but for the multi-objective and non-naive approaches, this is true, and this is in all the projects. There's only one exception in Rust, and if you want to know why, you can actually look at our paper, but we discussed that, why that phenomenon happens, but that's because of the lack of information that exists. So what we noticed is up to 1/3 of all the incorrect recommendations by code review recommendation could be stale, meaning it's just not only not going to help the developers, and even make it worse and waste their time. But how bad is it? Is it going to be like the person left yesterday? Oh, sorry, like it's okay, we can fix it, or the dude is ancient, we don't know him. So what we did to study this part is we calculated the number of days between each person left a project and the date that he's being recommended. Then for each quarter in the project history, we draw the distribution of those numbers, like 1 to 10. You can see it here for project Rosalind. On the y-axis, on the x-axis, this is the distribution of lingering in days, and on the y-axis is basically the distribution of those numbers. The orange one is Project Sofia, the blue one is cHRev, and the green one is WLRRec. We just studied non-naive ones from this point onward because we realized that the base naive approaches are not practical and they just do extremes. So we did that over different project periods and quarters. As you can see, it slowly moves forward, meaning the number of lingering days increases. And this is not just one project. Again, this is among all the projects that we've studied. And there are like these peaks. If you look at those like high intense areas, like there are like these high peaks. Normally, like there's one congestion in the beginning, but there's also like this part near the end that slowly moves forward. What we noticed is the recommended, like CR systems recommend people up to even years after they left the project, and it's not a good sign. We actually specifically realized that those systems that had reliance on expertise, they're worse in this matter. What happens is someone leaves the project, so they're expert and they keep recommending him no matter what because he's like the founder of the project. Who knows? But is it okay if we can only remove like top 10 from the recommendation, top 10 stale recommended recommendations, and magically like everything is gone? We should be good. So with that, what we studied is we studied like top 3 people in each time period for each project to see what's the percentage of their what's the percentage of all the stale recommendations that they occupy. So here you can see, like, for Rosalind we have sorry. For Rosalind, we have these 3, like the yellow one, the blue one, and the red one is one reviewer, is top 1, top 2, and top 3rd stale reviewers in terms of who being recommended more frequently. And now I added like all the 3 projects: Sofia in the middle, cHRev on the right, and WLRRec on the left, and we repeated that all the projects. What happens is over time, while like there are periods of time for some CR systems that these top 3 can occupy 100% of stale reviewers of this review recommendations. Over time, as you can it's more obvious in Kubernetes projects. Over time, it goes down. The reason being, it's more like the project gets more diverse. There are more experts leaving the project, and kind of like the stale reviewers being diversified, which is not something really good for filtering. So we have to come up with some other ideas. So what was our takeaway was like a small number of reviewers are frequently being recommended by CR systems, especially in the beginning. So while it's good to find them and remove them, especially in the early stages of a project, it may not be viable near the end. So in the paper, we discussed more. We came up with a solution of how to fix them, but here I was afraid that we may run out of time. That's why I decided to just keep it short. Feel free to have a look at the paper. There's a draft in the QR code I'm going to share. But basically, we discussed 3 different aspects of stale review recommendation systems: how prevalent they are, what's the duration of the lingering, and what's the distribution of the stale reviewers. I'm gonna wrap up with this. So we just started to talk about why this stale review recommendation happened. Then we moved forward and saw like how prevalent they are in different CR systems. We moved to the next part we showed that it's getting worse over time, not even better. And finally, we discussed about how removing top stale reviewers can help us in the earlier stages, but may not be the best solution for the projects that are old enough. With that in mind, if you want to know more about me or this paper, you can scan this. This is my best site. So